So looking at the bone lesions that we're working with, that we've identified across all horses, not just race horses, but across all the injuries that we deal with in horses. And we're dealing with long bone fractures, so a horse that gets kicked, something like that, breaks his leg. Could be from an injury from racing, could break the leg, but any type of fracture, we'll think that we need to speed healing in, because it's always a race. By the time the bone will heal and the horse is bearing full weight, what's the common scenario? They get laminitis in the other leg. So it's a real race to get those fractures to heal quickly. So that's what we're trying to work on. The other thing that we're looking at is we think is a big industry problem is OCD, or bone cyst, in young animals. We see a lot of that in our fast-growing horses, in our thoroughbred population. See it also in warm bloods. But it's a problem when you have a bone loss right in the area of a joint. So we think we potentially have some areas where we can work on in that disease process. The other thing we see a lot of is subchondral bone, and that's the bone beneath the joint surface. And we see that in the fetlocks as well as the knee joint and the third carpal bone. There's a big problem with slab fractures, things like this. Well, there's a lot of damage that goes into that bone underneath the cartilage, and if we can help repair that, we could potentially prevent those fractures from happening. Okay, so those are some of the areas that we have identified that we think are very important to tackle from an industry standpoint. The things that we looked at as far as sources, we always start from the bottom. We always have to start from the laboratory and then move outward. And so we start like in the test tube. So it gives us a little idea what's going to go on if in the animal situation. We always want to start in the test tube. And so the initial testing that we did with determining what tissue source might be the best for bone healing was done right in the petri dish, basically. So basically we looked at all the different sources: bone marrow, we looked at expanded fat cells, we looked at umbilical cord tissue and umbilical cord blood, all the stem cells from all these sources. And what we found that actually for bone healing in our situation is what bone marrow derived stem cells were the best for bone healing. Well, it kind of makes sense because they're in there right next to the bone, and so that's their job to help repair the bone. So it's not like that the other cells didn't actually make bone in the test tube. They did a good job, but bone marrow stem cells actually did the best. That's what we found. So the next step, though, we took it and actually tried to get bone formation in vivo, and there's a nice little model that we can actually use in rodents, or a rat model. And we put these cells, our stem cells, on these little, what we call wafers, collagen wafers, and it acts like a scaffold. And so basically we put the cells, we grow the cells up right into that scaffold, and then we implant them with some growth factors to have them grow bone. And we put them into an environment where they can actually have blood supply, and under the skin in a rat. And pretty soon we say that because of that right environment, you'll see those stem cells starting to make bone. So in that environment, actually, most of those cells did pretty evenly. So the bone marrow, the cord blood, and the cord tissue cells all form bone in vivo equally. So, and the test tube was a little different than the actual putting them in a rat. We're still working on the horse yet, so I don't have that information yet. That's next year. So we're working on models, so I can actually test what source will be the best in the horse. So I have a unique model that I'm working with that'll help me answer that question. So you can see it takes a little time to answer these questions, and to answer them correctly and make sure we're going to provide the best information, it takes several years. The other things that we're working with now is how should they be delivered. This is really important because we want to maximize the number of cells to the site, but also we don't want to do damage at the same time we're delivering them. So it's like when you're doing a tendon or a ligament injury, if it's a very small injury, it may be best to get those cells routed through the bloodstream versus right into the injection. Now, if you have a horse with a big bowed tendon and it has a big hole in the tendon, then it's probably going to be best to get the cells right into that big area of injury. So there's the route of administration, how we get the cells, really is going to depend a lot basically on the severity of the injury. Okay, so we're working on these things on how we should get them, whether we should inject them in locally, whether we should put them with growth factors, whether we should put them on scaffolds and then place them in there, or whether we should just give them intravenously or actually within the joint. And we're probably going to be doing combinations. So we're going to probably do combinations of local and systemic treatments. And that's probably going to be the way it's going. But these are the things that we're trying to answer. And so like looking at this case here, this horse has a bone scan. I don't know if everybody's seen a bone scan of a horse with bad fetlock problems, subchondral bone disease in the palmar aspect or the back of the joint. There's areas there where there's been bone damage as well as cartilage. Well, in those kind of cases, it's probably best to get the cells to the bone via the bloodstream. But you also have cartilage damage, so you probably need to get the cells into the actual joint. So you'd be doing both a combination therapy for those type of injuries. Okay, so what does all this mean? Those are some basic research questions that our lab has been trying to work with to help understand how these cells work. We still have a lot of work left to do, but each year we're finding more and more information on how to use the cells, what's the best source, and how to administer them, and what's the best time to administer them. But you know, it's not only the orthopedic injuries. As we start looking at these cells like the IPS cells, things like that, it's not going to be limited to the orthopedic injuries. We're looking at now these cells are going to be potentially used for neurologic disease, so you may be even thinking about these cells for use in horses with the wobbler's problem, things like that, where you have injury to the nervous system, as well as vascular disorders. And the key one that we think about is laminitis. And so horses that have had laminitis, that have a vascular insult to their foot, these cells have been shown in people anyway, and actually to help revascularization of tissue. So we think that they may be a good source for treating conditions like laminitis as well. So I think lots of potential. So the sky's the limit, I think. If we look at the parallel studies that are done in human medicine, and what Dr. Farrar was saying about Dr. Nolte's group having 100 faculty member and disease teams working on different diseases in people, that these cells have a lot of potential for many different diseases in horses. Now, the cases that we've done so far, probably in the range of 50 to 60 clinical cases. Most of the ones that we've been doing are basically with tendon and ligament injuries. And it starts off really, I'm a skeptic myself because I'm a scientist. And so I take the case where basically nothing else would work, and I said, well, I have nothing else I could try, so I'll just try some of the stem cell therapy. And started following a couple of those cases along. And you know, I get calls back from the owners and the referring veterinarians like, hey, that horse is doing pretty good. I go, what? How did that happen? And I'd get horses coming back into the clinic for follow-up. And one of our ultrasonographers who does the follow-up rechecks for the tendon and ligament injuries, who's really a skeptic, says that shouldn't have got better. And so there's definitely was some early anecdotal evidence anyway, and seeing a clinical response that said that where nothing else should have worked, that these cells were basically showing some signs of having a good clinical response. So since that time, now we're doing it more mainstream, and it's been going around the country, around the world. People are using stem cells on I can't say daily basis, but a weekly basis for equine orthopedic injuries. And those include tendon and ligament, fracture repairs, as well as joint injuries.